Chain of custody is the process of collecting and preserving evidence. So this is the separate process that needs to be followed very strictly, especially and it starts when a certain incident actually happens or when there is a crime scene. For example, if an incident actually happens, from that point onwards, any of the evidence that is collected that's relevant to that specific incident needs to be properly handled, and that evidence handling is called the chain of custody. This accounts for pretty much everyone who handled that evidence, and then who has access to that evidence, and any of the alterations that might have happened, and so on. And any of the analysis, as we discussed earlier, that's done on evidence needs to be done on a copy of it while you preserve the original. This chain of custody typically is followed through different documents. You can just use a spreadsheet, or you can have a formal evidence card, as you can see in the diagram here. So typically they have some of the main fields, or who actually obtained the evidence, when was it obtained, where was it obtained, and where is it stored, or where was it stored, and then who currently has control or the possession of that evidence. So this can take multiple steps, as the evidence can go from one person to another person before it actually reaches the final storage place. So it's important to document and have this card, and you can see that under the chain of custody for the evidence there are repeated different fields, so it can be going from one person to another, and all of this needs to be documented. Now in the last step, when you're actually preserving that evidence, you want to make sure that there is a serial number and that evidence is tagged properly in maybe some sort of a bag or a container. If it's a digital product, then you want to use some kind of a hash value in order to have some kind of a checksum, or make sure that it won't be altered and it has a unique ID. It needs to be placed in a secure place so that other people won't have access to it, or anybody who has access to it will have to sign out some kind of a log sheet, and then there's a record of that. And finally, you want to make sure that you get the signature of the recipient if you're actually receiving that product. So if you're part of some kind of a storage room or storage locker and you're receiving the evidence from different places, then you want to make sure that you get the details of who you're receiving that evidence from, and then get their signature, as well as provide controls so no other unauthorized access happens to that. Timelines are another tool that help with investigation. So they help narrow down the scope of the investigation, because when an incident happens, it can be a pretty large scope at the beginning. If, for example, you want to narrow it down to, say, this happened between 3 a.m. and 7 a.m. on a Thursday morning on the 14th or something like that. So that limits the amount of evidence that you need to capture, and then the focus is going to be within that 3 a.m. to 7 a.m. period, and then any of the time before that and after that, in order to capture any of the relevant information. So this can be dictated by legal documents as well, and also the legal hold that we discussed earlier is going to have an impact on this. So that will essentially provide with the actual scope on what data to preserve and for what period of the data to preserve. It's not just the timelines, but also the events that are also going to be narrowed down for that scope, and then that will help a lot more in investigating correctly. Now, during the timeline and the scope of the investigation, in order to get the relevant data, then you want to look at timestamps, especially for digital data. The timestamps are very important, and they hold most of the information and help narrow down the specific data that's required. It's essentially the date and time of when that document has been either created, modified, or accessed. those are the three main things that are available for files and folders in most of the computer type systems. There is a difference between Unix systems and Windows systems in how timestamps are handled. So Unix systems store the timestamps in a 32-bit value, and they start from January 1st, 1970, and then they just can't start counting up from there. So the first number is going to be the 32-bit value that corresponds to 1/1/1970, and then they just start counting up from there, and whatever the current date is. For example, you have a local date and time where you have Saturday, October 24th in 2020, and you have a time of 3 p.m. 24:11 seconds, and this is in the time zone of +7 hours. And if you look at the Unix time conversion of that same date time, it's just a long number. That's 16035278851, and that's the 32-bit value for that specific date and time. Now, if you look at the Windows system, it will store the same date and time as a 64-bit value, and that starts counting from 1/1/1601. So it will just be a longer number, but it will be like that Unix time. It can get a little more complex as well. This is also called the MAC-B, MAC, and in parentheses lowercase b times when you're looking at Windows and then you're doing forensic analysis. The MAC-B time is derived from the file system metadata, and they typically stand for M is modified, A is accessed, C is changed, and B is the birth. So this is the file creation time. And where are these stored? So these are stored in two attributes. One is at the standard info and the file name, and it's important to know the difference between these two. The standard info stores the file metadata like the flags, SID, the file owner, and the MAC-B. The standard info is collected by Windows Explorer, so it has the machine, timestamp, and all the other information that's useful for the system. Now, the file name attribute contains the forensic information and can only be modified by the system kernel. So users can actually change the standard info timestamps and the information that's there, but the file name attribute is the one that's actually more relevant for forensics, and that can't be altered. So there are actually some programs and there are some hacking tools that allow you to change this metadata, like the modified date, change date, and the created date, but even those tools can't actually change the file name attributes. So they can only change the standard info attributes, which you can basically see and tell. So that's why it's important to use specific tools when you're doing the forensic analysis, and in that case you'll be able to extract the file name information, and that can't be altered by anyone. When it comes to timestamps, you also want to make sure that the time offset has been recorded. Time offset is a difference between the system clock and the actual time. So there are some computers that keep their own internal time, and there are some NTP or some protocols that allow for synchronizing the time across different machines on the network and so on. But even then, you want to make sure that the system time is actually the same as the actual time, and if it's not, you want to take note of the difference or the offset. These timestamps are also stored in UTC, as we saw in the example, and they are converted to local times and the local time zone as required. So if you're looking at a report, and like a final report that's summarized, then you might just see the timestamp there, which is just based on the local time, or it can be based on some other time. So if the actual time zone is not specified there, then you want to go back and check the raw data, look at the 32-bit or the 64-bit number, and then convert that accordingly to the required time zone, because those numbers are going to be in UTC, so there is no discrepancy there. The evidence that's collected is not all equal, as we discussed earlier. So there are different sources from where this data can come from. Some of these are easier to collect than others, and some of them might even change quickly. So you want to make sure that there is a certain order that's followed when you're actually capturing or collecting the data in order to preserve it. So there is a certain order of volatility that you can follow in order to capture any of this data. So initially you want to make sure that the registers and the caches and the CPU type contents are recovered. So this data is stored within those CPU registers, and these data can be gone within seconds or even nanoseconds and be overwritten by other system processes. Then you want to make sure that you want to get data from the routing and the process tables. These are networking related, and a lot of the other operations might be able to overwrite them. Then you have kernel statistics, live network connections, and any of the data flows. Then you have RAM, which is your regular random access memory, temporary file systems and swap space that might be on depending on how much of that is allocated on the machine. Then you have the data that's actually on the hard drive, which can be data that's currently available or in the deleted space, remotely logged data, and then finally you have any of the archival data that might be on-site or off-site. Artifacts are items that demonstrate whether a certain action has happened or not. There are two main categories here. You have metadata and you have OS artifacts. Metadata means the registry entries, timestamps, and the size of files, and so on. When you're looking at the OS artifacts, these can be files that are in the cache, or most frequently used, or MFU, and also the most recently used MRU tagged data. These metadata artifacts are items that are used by the operating system and the computer for their regular process. So as we discussed earlier, you want to make sure that these are the principal data elements which need to be collected for forensic purposes. As more and more companies are using cloud services and pushing a lot of their processes and data to the cloud, it's important even for the forensic side to know the distinction between what's on-prem and what's on the cloud. So some of the data that's located on the cloud side or the cloud provider side might have different aspects and different rules and different terms of conditions than the data that's actually locally available here. So we can discuss that. So we discussed this in detail in the cloud security lecture, but at a high level, it comes down to what the contracts are and the SLAs or the service level agreements are between the cloud provider and the company. And anything that's legal typically is going to apply for event data that's stored on the cloud. Most of the companies are going to be using the major few cloud providers that are available, and they all have proper legal departments, and they all have different processes and procedures that can be followed if any litigation is taking place. One such thing that's important for the exam is to know about the right to audit clause. So this is a specific mechanism that helps verify that the systems are performing to the designed levels and they have the proper security and efficiency, and allows for an audit to happen. The level and scope of that audit can vary, and it depends on the actual requirement or what's on the legal document. So this makes the right to clause a very important requirement for any of the SLA, and typically if you're using any of the bigger cloud providers, this will be included. Another concept that's important for forensics is the integrity of the data. So this essentially means that any unauthorized change to an element or any of the updates or deletions that are happening need to be properly authorized, or they need to be documented. So some of the tools that are used for finding any authorized changes are hash functions, checksums, and data provenance. Hashing is used for digital forensics, for example, for digital signatures and so on. Checksums are the math algorithm that can provide with like a CRC check, or mostly they're used for looking for errors instead of actually looking for any unauthorized changes. Provenance is essentially the reference to the origin of data. So where did the data actually originate from? And you need to have proof of the data. So if you have illegal data, for example, on a hard drive, you need to provide with the data provenance and show that you didn't put it there yourself and it just happened to come there, or some hacker broke in and put the illegal data there, sort of thing. There are specific templates and specific procedures when you're dealing with data integrity. One of the popular one is the ALCOA, and then you have the results from that, which have to do with complete, consistent, enduring, and available. You may not have to learn a lot of this for the exam, but just understand that these concepts exist. And if you want to dive deeper into data integrity, then this is the one that you want to look into. So if you're studying for ITIL, project management type courses, then you'll encounter these concepts. Now, it's important to know the specific differences between hash functions, checksums, and cryptographic hash functions, because they all sound similar, but they do have different purposes, and they have different needs and different effects on forensics. Hash functions and checksums are sort of similar, whereas hash functions are used to look for unauthorized data and to verify the integrity of the data, whereas checksums are also used for integrity of the data, but more in terms of error checking instead of the actually checking for unauthorized use. The cryptographic hash functions are used typically for things like password hashing and to alter the actual data while keeping it still intact, and it has to be important that they can't be broken easily. So for example, all the passwords that are stored on a Unix machine are stored as cryptographic hashes that run through a proper cryptographic hash function.
For more details, check the link in the description. Learn with Whizlabs. Success certified.